Back in December, California scientists made a major breakthrough, a nuclear fusion reaction that produced more energy than was used to create it. Well, scientists have done it again, and this time their results produced even more energy. Joining us now to discuss the implications of this achievement is University of California, Berkeley professor Dr. Peter Hostman. Doctor, thank you for being with us. Talk, if you could, about how significant you think this is.
Thanks for being on the show with you, Jeff. Yeah, I'm glad to talk about this. It's we did again, I guess, right? So the scientists at Lawrence Livermore National Lab were really able to repeat and exceed, it seems, the power of the shots back in December. Now, what that means is that one can really plan for that, right? And one has all the parameters under control to repeat it over and over again as needed. And one can even get a higher energy out of it than originally in the first shots.
So fission is splitting things apart, which can be very powerful but very damaging. Fusion is bringing them together, which is much safer and potentially, in all ways, just better for everyone if it can be done right. A lot of people know what fission versus fusion is. Can you talk about the other words we've heard recently are fusion ignition? What is fusion ignition?
So in fusion, what you do is you take two elements, in this instance, deuterium and tritium, both versions of hydrogen, and they brought very closely together. In fact, they're brought so closely together that the repulsive forces are overcome. And so imagine like two magnets of the same pole putting together, and you're pushing them really hard together so they come together. Eventually, they will come together and become one new element, in this instance, helium. Now, in that wake of it, you change the weight of it. So if you weigh the deuterium and the tritium and you weigh the helium, they have different masses. And that difference is released in the form of energy. And so that energy is then released in the form of radiation and may be able to harvest it so we can make use of it going forward.
Doctor, how far away do you think we are from fusion being a viable energy source in everyday life?
Well, I think I'm quoting here my colleagues from Livermore, which said that this is similar sort of to the Wright brothers' first flight, right? So this is a proof of concept that one can generate more energy than is consumed in this. In fact, one can heat its surroundings so much that it's a self-sustaining reaction within that degree of it happens. And so that would be the ignition process. Now we are at that point where we can say we produce more energy than it's consumed. To really make it as a power plant is a long way to go. There's multiple things that need to be solved. For example, how do we get the energy out of this particular event? How is that actually harvested? How do we make the fuel so we have enough fuel to operate that machine and inject it at a high enough frequency that it's a continuous process and not one shot a day, but 10 shots a second, for example. And then we have to produce the targets, the fuel in a reasonable rate. And last but not least, maybe one of the very big difficulties is to have the materials that can withstand this very, very harsh environment that a fusion power plant poses on everything around it, surrounding it.
Other than the enormous cost right now, which makes it not viable currently, are there any other downsides to fusion?
Well, fusion, of course, does produce some amount of nuclear material, radioactive material. It's not without radioactive material entirely, but of course, it's much less so than fission would produce and less high-level material. Now, as you mentioned, the costs and the time frame by which it may happen is, of course, something we don't know at this point in time.
Doctor,
but
go ahead. Sorry.
Yeah, but it's very promising that we have this initial success here and really can show that more energy is produced than we consume, and that we did it again.
A lot of people have been talking about nuclear reactions and all of this recently because Oppenheimer has gotten a lot of attention at the box office. I didn't want to ask you if you've seen the movie and what you thought of it, if you did.
I've not seen the movie yet. It's on my to-do list for next weekend. But I've heard good things, and it was filmed right here in Berkeley, at least parts of it. And it was filmed part in Los Alamos, New Mexico as well, where you spend quite a bit of time. So it's a fantastic visit, and I'm very much looking forward to it.
Okay, I didn't know some was filmed at Berkeley, but that's interesting to hear. All right. Talking about fusion with Professor Peter Hostman from the University of California at Berkeley. We do appreciate your time tonight.
Thank you very much for having me.